Boom! All right, folks. So welcome to this video in our series on Surds. In this video, we're going to talk about division of Surds. And as you will see, here's where things are going to get a little more complicated, all right? In the sense that if you were paying attention seriously, you would have been, by this time you would be fairly comfortable and confident in terms of basic things, types of surds, addition of surds, subtraction of surds, multiplication of surds, division of surds. Things will start to get a little more complicated. But, like everything else, once you give it the required time, attention, and focus, starting with how you're looking at this video right now, and then you want to continue with some practice after that, you'll be okay. So we can break up the division of surds into several categories. Let us start by dealing with situations where you have two surds, two simple surds. So if you divide in two surds, let us say you have root 2 divided by root 3, right? You know that we could write that as root 2 over root 3, which is to say that you have two simple surds represented here. You have a simple surd in the numerator, and you have a simple surd in the denominator. So you represent division using the fraction notation, using the denotation of a fraction, which is very common. You would be aware of that by now. And once you do that, you start to move into a different kind of territory now, because this will simply give you as the final answer the root of 2 over 3, right? And the reason why we can do that is because one of the rules of indices, which we already covered in previous videos, one of the rules would be that a to the power of n over b to the power of n is equal to a over b all to the power of n. Of course, if you make n equal to a half, you'll have that a to the power of a half over b to the power of a half is equal to a over b to the power of a half. And of course, as we did before, if you substitute the half index with the square root sign, that will evolve to root a over root b being equal to the root of a over b. Right? So you could see then that the surd factor doesn't have to be the same to divide, as was the case with multiplication. It is not necessary for the surd factors to be the same if we divide in, because we can now use the rules of indices to give us the particular answer that we're looking for. And that is as straightforward as it is if we have to divide two simple surds by each other. Of course, we could then extend the argument by dividing a mixed surd by a simple surd, or a simple surd by a mixed surd. We could do that too. So if we want to, let me use the same 2 and the 3, just for simplicity, just for continuity. If we want to say, for the sake of argument, if we want to say, let me say 4 root 2 over 2 root 3, we could do that. That's two mixed surds divided by each other. 4 divided by 2 is 2. Or we could do it as 4. What you'll end up with will be 4 over 2 multiplied by root 2 over root 3, which, based on what we know now, 4 divided by 2 Well, let me just write it over like this just to make the point. 4 over 2 by the root of, 4 over 2 by the root of 2 over 3. 4 over 2 is 2, so you get 2 by the root of 2 over 3. Now we could also write that as 2 root 2 over root 3. And we come into that in a little bit. Let me just chuck it up in the corner because we actually setting up the next video now. But we'll discuss that a little more coming on to the end. So I'm chucking it in the corner here, 2 root 2 over root 3, because we need to refer to that a little later. Alright? So you can have 2 root 2 thirds, 2 root 2 over 3, or 2 root 2 over 3. Either way you want to write it is no problem. In surds at this level, we would normally end up with this. And then there's another process that we will introduce in the next video. That is the process of rationalization. We rationalize the surd. Alright? Suppose we have 4 root 2 over root 3. We could do that too. We can just leave it as 4 root 2 over root 3. Or we can simply write that as, 4 root 2 thirds. It all depends on the context that we're operating in. There will be contexts where 4 by root 2 over 3 is what we want to write. There will be other contexts where 4 root 2 over root 3 is what we want. No problem with that. I'm just going all out to show you the different ways in which we can express the thing. Alright? How about if I have root 2 over 2 root 3, let me say root 2 over 5 root 3. Alright, root 2 over 5 root 3 is just that. Root 2 over 5 root 3, we can leave it like that. Or we can say that that is equal to 1 over 5. Right? The 1 would be understood here. Multiplied by root 2 over root 3, which as we know by now would be 1 over 5 by the root of 2 over 3. We could say that too. So there will be contexts where this is what we want to say. 1 over 5 by the root of 2 thirds. Or there will be contexts where we want to leave it simply as root 2 over 5 root 3. Let me chuck this in the corner here too. You might want to say root 2 over 5 root 3. We come into that in a little bit. So you can have two simple surds divided by each other, which will just give you a whole fraction under the square root sign. Or you could have a mixed surd or an integer in either the numerator or the denominator, in which case your regular roots would also apply. Sorry, not regular roots. Your regular, what's it you're looking for? When you reduce, right? You divide and all of that, and you break down the thing. So, for example, if we had 12 root 7 over 2 root 5. Let me say 12 root 7 over 2. 12 divided by 2 is 6. That would just be 6 root 7. If you have 12 root 7 over 5 root 2, not 5, sorry, 3 over 3 root 2, right? Your cancellation, that's what I was looking for. Your regular division, 12 over 3 is 4, so you get 4 by root 7 over root 2, which you could write either as 4 root 7 over root 2, or you can write it as 4 by root 7 over 2. It all depends on what it is you're trying to do, what you're trying to accomplish. Right? Which then leads us to the other thing. Let us say that you want to have an integer divided by a surd, or a surd divided by an integer. You could do that too. Simple surd, that is. So you could have, on the one hand, you could have root 3 over 2, where you have the simple surd in the numerator and the integer in the denominator, or you could have 3 over root 2, where you have the integer in the numerator and you have the simple surd in the denominator. You could have that too. So in other words, there's nothing else you could do there. You can't simplify this, except for a particular process that we apply to surds. Alright, a process which we will discuss in the next video. No, that wouldn't apply here. That will apply here. 3 over root 2. Right? If you set up the next video, you know, there's a particular process that we use when we're dealing with surds where we have a numerator and a denominator. Let me make it a little more interesting now. Yeah? So what about where we have compound surds? Let me make life nice. Let me make life nice. So if we want to say, we can say, we can say 5 plus root 3 over 2, where you have a compound surd in the numerator and an integer in the denominator. Or you could have 5 plus root 3 over root 2, where you have a compound surd in the numerator and a simple surd in the denominator. Or you could have 5 plus root 3 over, let me say, 1 minus root 2. Where you have a compound surd in the numerator and you also have a compound surd in the denominator. Or you can have 5 plus root 3 over 2 root 2, where you have a compound surd in the numerator and a mixed surd in the denominator. You could have that too. Or you can have it in the reverse. Let me flip the script now. So instead of 5 plus root 3 over 2, you could have 2 over 5 plus root 3. You have an integer in the numerator and a compound surd in the denominator. Instead of 5 plus root 3 over root 2, you could have root 2 over 5 plus root 3. You have a simple surd in the numerator and a compound surd in the denominator. You could have, as we have here, a mixed surd in the numerator and a compound surd in the denominator. 2 root 2 over 5 plus root 3. And just as we had here, you could also have 1 minus root 2 over 5 plus root 3. You have a compound surd in the numerator and a compound surd in the denominator. So in other words, you could have different types of divisions where surds are concerned. And each scenario, each situation comes with its own associated arithmetic process, its own particular arithmetic procedure. And one such procedure that we want to discuss in the next video, a procedure that is very, very, very important. This is where a lot of people start to get unstuck, where surds are concerned. Everything up to this point, we okay with. And then they will say, sir, I understand surds, but I don't understand rationalization. All right. So here we will and do. We will take the next video. And even that next video, we might have to split into 2 or maybe 3. So we're going to deal with the concept of rationalization post this video. Let me write the word on the board so you can see it for yourself. The word of the day is rationalization. Rationalization, right? That is the what? Rationalization. That is the noun. The rationalization as a noun. The verb is to rationalize. Right? This is the verb as a noun. So, look out for that in the next video. So stay tuned. We have more coming up.